starting now.
Okay, today we're going to solve LeetCode number 2270 called Number of Ways to Split an Array. So you're given a zero-indexed array, nums of length n, and you basically want to know how many ways there are to split the array so that the left sum is bigger than or equal to the right sum at each index. So, for example, this has two splits because when we're on index 0, the left sum is including index 0, so 10 is bigger than 4 plus 7 minus 8. So 10 is bigger than 3, so that's result plus equal to 1. And then when we get here, same thing, so 14 is bigger than negative 1. That's 2. When we get here, the story's different because right now 10 plus 4 is 14, minus 8 is 6. 6 is not bigger than or equal to 7. And then we do the same thing here, and 7 is not bigger than or equal to, or 7 is bigger than or equal to this, but notice in the question it says negative 1, so we don't care about the last index. So at the end, we just return the valid number of splits, and some more examples here. So let's come up with a brute force way to do this. So we're going to declare a result variable. We can iterate through the input array, and naive solution is just to say if the sum of the left side up to and inclusive of the current index is bigger than or equal to the sum of the right side. So I plus 1 to the end.
Mm-hmm.
If that's true, then increment result.
Mm-hmm.
And if you run this, it will probably get time limit exceeded because this is not very efficient when the input is very large, but we'll see.
Yeah, it's take too much time. Oh, okay. Wrong answer?
Looks like I made a mistake because, so we're including the current, and then, let's see here. Is it I to the end? Oops, sorry. The mistake was including the last element. So, okay, this should pass most of the test cases, but we'll time out, I think. So, as you can see, this passes 92 out of 101 test cases, but the input is really large. So, we're almost there. So how to make this better? The way to do that is to calculate the total sum of the array and make a smarter decision, because you know that by using the concept of a prefix sum, we can already tell if 10 is bigger than the right side. So let's say we have a left side variable here, and we're still going to iterate through the input array. But what we're going to do is we're going to add the current element. So now left side is equal to 10. And at the same time, we are going to subtract that element from the total sum. So the total sum, 10 plus 4 is 14 minus 8 is 6 plus 7 is 13. 13 minus 10 is 3. So at this point, if the left side is bigger than or equal to the total sum, then we can increment result. Got this variable here. And this is much more efficient because we are already pre-computing the sums without recomputing every single, however long the rest of the array is and before the array is. So for example, when we get here, which is a last index because we're supposed to do -1 actually, left side becomes 14, or 4 actually. Let's go one by one. Total sum becomes -1. 14 is bigger than or equal to -1, so result becomes 2. -8 is the last one. Left side becomes 6. Total sum, -1 minus 8 is 7. Because, when you minus, it becomes plus. So now left side is not bigger or equal to right side. So this does not increment.
Mhm.
And then we hit our loop limit, and then we can return result. So this is a more optimized way to do it.
Oh,
you can
wow.
see,
Okay.
Passes all the test cases, and we're at nearly the top 10% of runtime and memory. So
Okay, I think you make a good decision here. You using the prefix sound, right? So what is the time capacity?
time complexity now, instead of O of n, is actually O of log n.
Why is log n?
Because we don't have to recompute these sums every single time.
No, it's
We're
not
only
log
computing
n.
total sum 1.
It's not log n. I think it's b of n.
Big O of n? Okay.
Yeah,
So
yeah.
what is the time limit exceeded then?
What's time exit?
When I did it my old way, what kind of time complexity is that? Oh, that's O of n, that's O of n squared. Okay, this is O of n. Okay.
Yeah. Okay.
But I know memory complexity is constant over 1. We're not using extra memory, but okay.
Yeah.